Hi, good afternoon. Welcome to the post-launch session of eTestCon. I am Saujanya Kota, responsible for handling the TESI product line at Menlo Park Technologies. Early this morning, we had detailed learnings on mutation testing and Ethernet switch testing. We now move forward to get hands-on usage of TESI tool, wherein we would get trained in designing the test cases using classification tree editor. We will implement the knowledge gained during our technical session on mutation testing using relevant examples. Delegates who have just joined, the trainer for this session is Mrs. SHASHI, Senior Software Engineer at Razorcat GmbH. Menlo Park Technologies is a leading provider of design, development and testing tools to device software manufacturers across automotive, aerospace and industrial automation customers. Menlo Park Technologies provides certifiable product support and technology-driven training as a value addition.
Hello everyone, and thank you so much Saujanya for the brief introduction. So today's workshop topic is classification tree editor and then mutation testing. So we will see how we are designing systematic test case using our classification tree editor, and next we will apply mutation testing to check our quality or to enhance our test. So just let's talk about the process or a standard workflow of unit testing. So I will say first step, what we do is we identify our inputs or our interfaces, like what are the inputs, what are the outputs, and next we create a test spec or test specification. And once we are done with creating the test specification, then we move to converting those test specification into our test data design. So our classification tree editor is based on classification tree method, which actually provides a systematic approach to create test case definitions, based on functional specification of function or system to be tested. And this CTE is included in TESI, which helps us in creating, you can say, low redundancy and error sensitive test cases. And as I said, classification tree editor is based on CTM, that is classification tree method, and this method's basic concept is to first partition the set of possible inputs for the test object separately and also from different aspects. So we gather all the inputs, outputs, you can say global variables, function returns, everything, and once we are done with that, then we combine the values to obtain redundancy-free test cases covering complete input domain. So we see today's highlights for this workshop is, I'm hoping many of you are new to TESI, so we'll see the project creation, how we create, then next test case design, and we will look at the manual test case design. So we don't use CTE here, and we see how long it takes if we design the manual test cases. And next, we take help of CTE and design systematic test cases. Also, from TESI 4.2 and above, we have implemented automated tree generation. There we can have, this classification tree already generated with our TESI based on our interfaces as input. So we'll see that. And after that, we will look what are the advantage of, using CTE over the manual test case design. And also one of the important step in, testing phase is documentation of test case specification. So here we will see how CTE helps us to document it, in automatically. We don't have to write them. And after we are done with CTE, we will apply mutation test to check the, already created test, whether it's complete or not, or how strong our tests are. So I have taken one small example. Just to get an idea what we are trying to achieve. So I have a function, and the input of the function is something called temperature, and I can range the temperature from maybe just let's say -20 to +50. And the functionality of function is something like if it is in this range, maybe -2 to 11 degree, then my heater should be on. And if in this range 12 to 20, then we are doing nothing. And if it's beyond 21 degrees, then we are switching on our air conditioner. So first I will think, okay, let me identify what are the inputs for my function. So I have one input, then I will, partition or categorize my test data based on the functionality, or you can say based on equivalence class or boundary values. Once I'm done with this one, next I will say, I will pick set of values to create the test cases. So I will say, okay, let me create one test case, and I'm picking temperature from this range. Then of course my heater should be on. Then again, next test case, I'm picking from this range. Then I'm doing actually nothing because it is a valid. And next, I have picked temperature from 21 degree or in this range. Then in that case, I will say, okay, my AC should be on. So we will see how this, visualization can be done in CTE. Otherwise, in TDE, if you do it manually, we don't see these visual things. So we can switch to Test Case now, and we will implement all one by one. And the major steps for creating a systematic test design using CTE are basically two steps. So I can say first, identification of the test relevant aspects. Those are called classification. So here I can say the variables, they can be input output variables, and input can be global variables or parameter to the function or function returns, and then corresponding values for those classifications, and those are called classes in tree editor. So once we identify all the interfaces or all the test relevant aspects, we also create some set of values. And once we do this, how we are doing this, so this is usually done according to functional specification of software under test, and these aspects represent the input and output data of the test object. So as I said, once we analyze our code, we identify our inputs and outputs, and that after doing that, we set these interfaces in test interface editor in Test Case. And from there, actually, CTE picks up these aspects and takes into account. And after this step is done, next we are doing is like combination of different classes from all the classifications into the test case, meaning all the values we have created for all the variables, we are picking particular set of values to create particular test cases based on our functionality. So, okay, let's switch to Test Case now. Okay, so if you have created a project, well and good. If not, then we can create now. So now also I would like to create for this purpose. So to create that, what I have done is I have, created one folder for this to create all the Test Case project and all relevant files. So this is my folder. So I will create my project here. So you can go to File, New Project, and in project root, I'm giving the same location and name. Maybe I can write workshop. And here I will say enable source root and I will take the same path so that it's easy when we, add our source file. And I'm using the default configuration, so you can leave this empty when we are using the default configuration, and these things are, the project, the location for our database and backups. So you can say okay. Yes, so here you can see this was not there. Now Test Case project is created, and I can see one folder created there that was Test Case. Now, so now there is nothing, and as I said, I had here I had set my source root as project root. Why I did that? Because so it will be easy. I may create now 2, 3, or 4 test collection, and when I add my source file, it will be easy to import directly. It will navigate to this root. So for that purpose, what I am doing, I'm storing my source file in this path. And also for this demonstration or for this workshop, we are taking the same our standard source file that is called the example, which is value in range, and that you can find in installation path. So from there you can see your installation path is here. So program files razorcat, and you can go here and you can see this one is our code. So I can just copy this to my project location. So maybe we can create and yes. So I have created a project. I also have a source in my project root. Next, as I said, we have, either we can create CTE manually, or we can use the CTE which is generated from the TESI itself. So first we will go step by step. So first step, we will create it manually. So for that, we will disable the automatic creation. For that, you can go to preferences, and here you can go to CTE tree generation. So here we will see create initial tree based on interface. So I'm just saying don't create now, because we will see the difference, how much, how efficient if we take the automated tree, or how much more efficient it is compared to manual tree creation. So you can say okay. And also in metrics, right now these are not of our interest, so you can untick this and just leave only the a coverage and say apply. Okay. Now next is creating the test collection. So I will create one test collection, and maybe I will give it name as is value in range. And then I will have one module here. You can have a folder, but since we are tackling only one module, so I'm not taking this. So I'm directly taking the module. So, okay. And this I'm giving the name as is. So that it's easily readable, or, this is my module name also. So I have this project or collection, and this is my module. Now next part is to add our source file to be tested to this module. So for that, and also before that, since I had taken the default configuration, so my default configuration in TESI is our GCC GNU GCC Eclipse. So this is selected, and if you want to change your the environment, meaning the compiler or target, so you can go here and you can select which one you want. So suppose if you are testing this one or this one, you can say add to project, and you have to set all these according to your installation path and everything. But now we will use only the default, so I will just ignore this. Okay, so next part is adding the source file. So for that, you can go to properties, and here there is sources, and this you can add the source file with this. So as I have set my source root as project root, it will navigate there itself. So here you can see I had sources, so I will take this source. Now I have created the project, I have created one test collection, I have also added the source. So my next step is TESI only comes into picture after your code is correctly compiled, or it is compilable. It is it says compiled okay. So to check that, you can right click and say check source. So it says okay, compile okay. Then once it is compiled okay, next part is we have to expand and see how many test object or functions are present. To do that, we have to analyze. Yes, and if you expand it now, I have only one function here. So before as I said, the correct step will be to go to the code, identify the interfaces, like what are the inputs, outputs, and then create the test specification and convert the test specification into our test data. So let's go to the code. Okay, so this is my function, and as you all know, it is standard function is value in range, and the input is one structure and one variable v1. So it is checking whether my variable v1 is within this given range or not. So I have basically two inputs. One is structure and both the members, start and length, and the variable v1, and output only one I have, that is function returns. So if I have to set these interfaces as input and output, I would say these two, and this v1 will be input and the result will be output. So to check that, we have to go to TIE. And here you will see, okay, I have just the parameter. We are not using any global variables or any function calls here. So in parameters, I had one structure and the variable v1. So they are correctly set as input and result is output. So, okay, one part is there. I have identified my test relevant aspects. Next is to, create a test case specification. So I would say, let me think like, okay, I can take based on equivalence class and boundary value, I would, create some 4 or 5 test cases. So I can create one for maximum, one for 0, maybe one for minimum, and others for some random values. So let's create few test cases. Okay, so here I can see, okay, this is my minimum, maximum, and I can say take some random values here. And in random values, maybe we'll pick some more test steps. So 1 and 2. So again, if I have to write the test spec, so first I have to think of creating the test spec. So I'm taking all minimum. So in that case, I can write it here. And this is the correct way actually. So I can say, okay, my inputs are going to be, what was that? R1 dot range start and similarly R1 dot range length, and next was v1, and these 3 were the inputs, and output was just the function return. So for first test case, I am targeting to get all the minimum values. So I'll say, okay, take the min. And in that case, yes, it should be within the range. So I can say yes. So you can say, okay, I analyzed my code and I decided what I'm going to do in my first test case. Same thing I can put for max, but I will change it here as max. then it should be no. So again, if we go on writing this, it is a bit of manual. So I'm leaving other test cases and directly I'm creating the test data here. So as we saw what we had seen, and this was my max. Zero. And here let me give some random values. So suppose 5, 10, we can give 15, 20, 25 and 30. And let me give something like it should be outside, so I can say 2, then okay. And here maybe 40. And this we can say maybe 45. And based on this, I'm expecting this to be yes. And here it should be no. Here it should be yes. Again, this is no, no. And here this will be definitely 25 plus 30 is 55. So it is within the range. So yes. Now, so I can say my test data is ready now. Let's try to execute. So we'll take just our standard C1 and MCDC coverage. Yes, so it covered C1 and MCDC also, and I'm thinking, okay, I have covered all min, max, and equivalence class also. So this design we did manually, like also we have to document the test spec, we have to write it manually. So let's try with CTE, and also first step we'll go with CTE and manual CTE creation. So I will create one more test collection for that purpose. Maybe I can say IVIR manual. And here again, I'm taking the same source. So let's add the same source. And again, compile and analyze. Yes, so as I said, the same thing we will try to create with CTE, and also the CTE we are creating manually. So for that, again, we have to first check our inputs, whether it is correctly set or not. So mostly in analysis phase, it will be set correctly. So I have 3 inputs and 1 outputs. So let's switch to CTE. And here you can see there is only one functional node, which is as same as your function name. So I will say, okay, I have few inputs, and in inputs I have few variables, and in those variables I can categorize, or I can set few input values. So there are something called composition, classification, and class. So composition is something like, okay, in input you can put many variables. So input I can tell, okay, this is composition, and classification is something like, the individual variables, and class is the individual value. So let's pick two composition input and output. Yes, and input, I have 3 inputs here, start, length, and v1. So we'll take, so again, I said the variables are nothing but the classification. So I'll take 3 classifications. So I can say, R1 dot range start, this one R1 dot range length, and here are, this is just my variable v1, and this I have also an output side only. I have one, that is my function return. So I can just say, okay, return. So this is done, and next part is, now this is like, it's independent of your interface. It is not linked. So to link, what we have to do, you can just select here and say attach to CTE node. So here you will see now it is attached. So whatever you are creating, whatever classes we are creating here, it will be assigned directly to this one. Similarly, we will do also for length. So variable v1 is here, and return is this one. So I have created a tree and I have attached the node. Next, I'll create the values, different possible values I want to, test for. So for that, I will have few classes. So, okay, let me take one. So maybe I will say min. Zero, and random we can give 20. And this max. And we can see all the data types of variables are same, so I can reuse it. So how can we reuse the similar thing? So because minimum maximum is going to be same, and equivalence class we can change a bit. So for that, you can copy the whole class and paste it somewhere and define the parent. So you can just pick this and say okay. Yes, and by escaping, we can just leave the selection. Similarly, for v1, I can change only this one. So I can make it 30. Again, for this, I will do same. So I can paste it again. And I define the parent. Yes. And in return, I know it will be either yes or no. So for that, we create two class. And to align it, you can just select and press here, and it will be aligned a bit. So I can see my first step is done. I have identified the test relevant aspects and created the class for that. And next part comes my creation, or maybe systematically I want to create few test cases. So the functionality of this function was something, whether my value is inside the range or within the range or outside the range. So similarly, I will try to create 2 test case and few test steps under those test cases. So let me create. So I'll say, okay, create test sequence. Sequence is something like, test case and test step. So it is like test case parent, and within this we can create test steps. So I will say within the range, and one more I will create outside the range. In this, let me create some 3 or 4 test step. So I can say, okay, create test step 1, 2, 3. Here also 1, 3. So now I want, so you can see here it's like pictorial view, and here I can, the test cases are quite systematic way. So I will pick the value so that I have the output as yes. So maybe let's try minimum, then my output should be yes. Similarly, if I try for 0, then it will be yes, and if 20, then yes, 20 plus 30, 50. So here let's change it to 40. So it falls within the range, so yes. So this, if you see here, I have the set of values, and here I'm creating the test case, and this bubbling is nothing but just by bubbling you can pick the set of values or set of inputs, and it creates your test cases here. And here we will try some values like maybe maximum, then it should say no. And if we say something like 20, 30 and value, let me give 0, then again it will say no. Then again let's see some other 0 maybe and max, and if I'm giving the value as min, then it will again fall, like it's outside the range. Now if you save, let's see how it changes. So you can see here also it will change. Yes, so here you can see this is blue and these are yellow, means we have a node attached plus the value assigned. So the moment I saved, the value has been assigned here. And this selection, since I have selected this, suppose you want to change or you want to know which node of the classification tree this corresponds to. So you have to just select here, then that node or that particular classification will be highlighted as blue. So suppose I want to check for this one, then you can see here all the classes are blue. So this again blue and this one is blue. So you can see now my test spec is ready. And next, by saving it, this gets converted into my test data design. And we can see that by going into TDE. So yes, if we compare from previous one, we did the same thing, but we had to enter manually. And here, we just need to create the CTE, and we just, by bubbling, we get all the values here. And let's try to execute again. Okay. Yes, so you can see all MCDC and C1 is covered. Suppose it was not covered and you feel like, no, I want to add, few more test cases. Then if you do it in manual, then you have to enter them manually. So if you do here itself, then you can go to CTE. And maybe I will say, okay, let me randomly, create some test cases. Maybe 1, 2, 3, and something, let's check 20, 30 minimum. then of course it will fall outside the range. And similarly 0, 30, and let's take maximum, then again it will fall outside. Again, let's check something 0, max, and 40. Then it should be yes. So you can see just by bubbling, you get the test entry here, test cases entry here, and now we just have to execute. Yes, and one more thing, if you are doing it, manually, then you don't know if the test cases are repeated or not. So CTE, as I said, it creates a redundancy-free test cases. We will look how. So you can see, suppose I am creating one more test case, and I'm copying the same, maybe from first I will say min, and yes, and let's try to save. Okay, or maybe and let's execute. Yes, and as I said, maybe let's remove this max from everywhere. Yes, so here there is a validation. So it says each class should be marked at least one test case or one test step. So here this I had created and I thought of using, and also we had to use this value, but I have not used anywhere. So for that it says here you can see validate, and it is verifying whether any value is left out or not. So we will pick it back. Yes. Then it will be gone. So it's 0, 30, and no, so we should give something maybe 40. Okay, so this is how a manual tree creation also helps us to reduce our effort, and also, and again, if we look at my test specification, right here, you can see it is automatically written here, and you can say it's documented. We don't have to write manually. So this we saw like how we are creating tree on our own, and we are not using from TESI. Next, we'll see how more efficient is CTE when we use it from automatic tree creation from TESI itself. So for that, let me create one more test collection. Maybe I will say true and auto. Again, I'm taking the same source. And add the source file. Yes. So let's check our TIE. So it's correctly done. And next part is CTE. So as I said here, we will use the automatic tree created within our TESI. For that, as we had disabled earlier, we will enable first. So in CTE, I want to use it from TESI itself. So I will say, okay, take it. So create initial tree based on the interface. So based on my TIE, what are the input variables, output variables it picks, and it creates all the classification and the classes. So we'll say yes, apply. Now here, if you see, when we had gone to CTE, we only got one node, the functional node, which just says the function name, and we had to create this and we have to attach. If we look here now you can see earlier it was only this, but here based on our test relevant aspects, or based on our TIE set interface, we can see there were outputs and inputs categorized, and in inputs we have parameters and two parameters. One was structure and another one was variable, and within the structure I have two variables again, start and length, and variables is just the variable. So here you can see how systematically it is picking up and categorizing, or you can say partitioning as per our set TIE interfaces. And so this is nothing but the last variables, and these are the classifications, and they are attached to our TTE. So that we will see. Earlier we had to attach. Now you can see it is already attached to R1 range start, and this is to length, and again this is to value. And again, the idea of CTE is to create test spec based on all the inputs. So based on all the combination of inputs, so it's quite difficult to predict the output. So in output you can see it's only the default new class, and that is also commented out. So if you know what are your outputs or expected outputs, we can create here. So I can say yes. So in this case, it's easy because it's kind of, enumeration, and it can be only yes or no. So I can take okay. No. Now, so my classification tree is ready. Next comes my creation of test case. So let me create again some 3 for both inside the range and outside the range. Yes, and here we will again create okay. So let's pick few combinations. So as my result gets yes, so maybe I'll pick again minimum, and yes. And let's take -1, 0, and -1, then it should be yes. 0, and let's pick maximum, and let's pick here maybe 1. Then it will be yes again, and let's pick some values so that my output gets no. So let's take max, no. And again, if I try, let's take maybe 1, and length also 1, then 1 and 2, and if I take just say 0, then it should fall outside. Similarly here we can try maybe maximum, let's say -1, and again the maximum, so obviously it's falling outside the range. So here if we saw, we saved it, and the moment we saved, this is already assigned here. And let's get back to TDE. So yes, compared to this one, we did not even have to create my CTE or create my tree. Only thing we had to just create classes for our output, which is very less effort. And let's again execute this. Okay, so you can see just by by creating, this was already created, and I just analyzed how I want my test cases to look like, and I segregated like within the range, outside the range, and I just picked some combination of inputs, and I decided my test design, or I just converted this test spec to test design. So this was how we are using our automated tree created for our systematic test design. And again, if we look at here, you can see it is, if you look at test spec, it's quite good. You can see input, and it is coming from parameter, and the structure members, what are the values here, and for value, what are the values here, and what is it returning. And here, if we look, if we compare from here, although if you write, it might not be very, it might not look very proper. And to write it in a very proper way, we need little more effort. And here we can see it's very well, documented, like automatically from CTE. And next, I'm getting an idea, like, like earlier I said, maybe I want to create some more test cases out of it. Then you just have to go to CTE and create some test cases and just bubble them, and it will be converted here to test data, and you just have to execute. Now, another interesting feature is something called, instead of picking this, suppose I want to create my test cases, or I want to design my test design so that it picks all the possible combination of all the input variables, together. So how can we do that? Like I have 5, 5, 5, all 15 class I have. So I'm taking all possible combination. And also, as I already said, the CTE, the main goal is to, create a specification based on our inputs. And for that, I will just select input and say generate test cases and all pairs for selection. So it will create all possible combination for inputs. And in this case, we know it's quite, we cannot predict now itself, and it will be little a tedious job. So we can leave this output and we can go to TDE. So yes, you can see I have some 25 or 23 more test cases generated, and with all the test spec taking different values into account. So to get the correct output here, first we can just execute. And this we can say just, copy actual to expected. And after we do this, you have to check, it will be like, it will be correct only, but we have to cross verify before you say, okay, it's correctly taken or not. So suppose we take this one, or this one, so -1, -1, 1, definitely it's going to fall outside. So, okay, it's correctly done. Again, you can take some random one. So -1 maximum, and this is minimum. So again, it's outside. So like this, you can just, after you copy, you have to cross verify once, then you can save. And again, if you execute, yes, so you can see just in one click, you have n number of test cases and taking all, possible inputs or possible combination of inputs. So this was my, manual and manual tree creation, and here automated tree creation we are using. Next, we suppose you are testing something called variant handling or something. So for same software you might have two variants and the software will differ in a very minimal way. So in that case, definitely you might know about reuse of your test case. So we'll see how the CTE test case design can also be reused with this IDA, and everything will be copied into the target test object, like all the test spec and everything. So for that, I will create, maybe let's create one more test collection. Three, and I can see reuse. And again, we'll take the same source. Yes. So let me take from this one, and let's see whether everything comes here or not. So for that, you just have to select the target test object, go to IDA, and either you can double click or drag and drop the source. So yes, everything is same. And if you are testing something called variant handling, right? So I'm guessing like it will only be, the name change will be there or something. So you can just drag and drop and everything will be reflected in your target as changed one. So you can say, okay, commit. Yes. So again, one good thing about this, again, let's execute. So here, if we see this, half of the outputs were done manually. So one good thing about IDA is it takes also from CTE, and also if you have entered something manually here. So this was about reuse of CTE designed test case. And one more task it helps in something like, if you want to share your task. So suppose you only have one TESI license and you are testing a module which has you say some 50 functions, and if you are testing it alone, of course it takes more time. So we are getting an idea, maybe what if I have the CTE as standalone application, and I'm creating all the test spec in my CTE standalone application, and later I'm importing here. So let's see how. So basic idea is, let's create one more for that. You can say import. Yes. So as I said, suppose I have many n number of functions in my test, and few numbers of function I want to give it to, say, person B to at least complete my test spec using CTE, and later I can import and I can just execute. And of course, for that, what we can do, first thing, obviously, we have to go to TIE and set everything. Then you can go to CTE and your template is ready. So this one, you can save. And once you have saved, this CTE will be saved in your project location. So here it is saved. So the person B who doesn't have the TESI license, but he can at least complete your test spec part or test design part, he can take this one and, import in CTE standalone application, and which we are working on it, and we are expecting it to be coming on, beginning of the next year. So parallelly, you can work. One person can work in CTE, and another person can work in, TESI for another test objects. So he can take this and work on it and complete the test specification. So suppose I have one completed for example, this one. And he has completed and he has stored in, suppose, say, location here. So we can see, okay, 463, 464. Okay. So from there, I will import now. So I can say, okay, from file, yes. So since it was already saved earlier and it has one template, so I can say, okay, just replace it. Yes. So again, CTE was, independent application when he created. So this only thing we have to do is this. You can see there is no attachment. So only thing we have to do later is just attach. So it's very less work again. So I can say, okay, let me attach. Yes. So now all the classifications are attached to my inputs and outputs. So I can save. So you can see, okay, now everything is assigned and this is imported. And one extra thing we have to take care is, since I have taken from CTE, so this was not bubble. So again, we have to repeat the similar process in this case. So you can execute. And here you can say, okay, take actual to expected, save, and execute. Yes. So this was all about, CTE. So I guess we are running out of time. So we have some 10 minutes more. So let's try to apply our mutation test in any of the test collection. So let me try with this one. Or we can also copy. Or for clear understanding, we can create. Okay, and again, we will take the same source. Yes. So let me take the values or the test data from the first design test cases. So I will take it from here. Okay. And since my purpose here to check if I have not designed my test cases properly, then in that case, maybe we will just delete these because they have min-max. So I'm expecting they will kill the mutant. So Okay, so now let's execute with mutation and see how it looks. Yes, so here you can see mutation score is 0% and there were 2 mutations generated based on our settings, and none of the mutants were killed. So again, as I had already explained in mutation testing technical presentation, we can set our the settings here as you want. So here, this is my settings right now as the default, and we have already discussed in the technical presentation, so I'm just showing it here. You can also customize. So in this case, I had 2 operators. One was less than and another was greater than. So this has been replaced with this and it has generated one more mutant, and this was replaced with this and it has generated one more mutant, but none of the mutants were killed. So to analyze that, we can go to coverage viewer. So you can see, yes, there were 2 mutants and none of them were killed. So to do that, I'm just guessing, yes, I hope, I'm just thinking, oh, I have not tested for boundary. Maybe it's not hitting the boundary. And here also, and if I look here, then 5 and 15. So the range is between 5 and 15 and it is 2. So it's, away from 5. And again here 15 to 35. So this is also little away from, 35. We are not hitting the boundary. So let's take all the test cases now, or maybe we can again. Now let's apply again how it looks. So here you can see there were 2 mutants and both are killed. So to analyze that, you can go to coverage viewer and you can see, okay, both the mutants are killed, because we have, if you compare compared to previous test case, which only had 3 test cases, now we had added this, and also it looks better. So you can see if someone has tested in not in a very good way, mutation test can detect at least like it is not tested for boundary or something. So this was about CTE, and next the mutation testing, how we are enhancing our test data. So to summarize, I would say classification tree editor, what we are getting, so a systematic and easy understandable way to create test cases in a graphical editor. And next, partly it is also partly automated generation of test case specification. So this part I will also show in the reports. We can see it, test spec is also documented. Next, we can export the CTE and CTEX file, and we can import in any other tool, for example, TESI. And good part is CTE is integrated into TESI. And similarly, mutation testing, what we are getting, it can reveal weak or insufficient tests. It can detect potential bugs and poorly tested code. And it automates parts of the test review. So it is reducing the effort of test review, and it increases the confidence into the test suite. So I had discussed about, the documentation of reports. So let's try to generate one of the, yes, the report here. So we can generate. Okay, and you can merge details, so everything comes into one document. and we can go to that path. Yes, so here you can see there is something called test spec, and if you have not created with CTE, right, this will not be there. And if we see here, it is documented properly as in, we had created in test C. And also if you go to all the test steps, this has also been documented here, what inputs were considered, and based on that, what outputs we had done, like, in a return format, in a Word format. So like this, we can also document our test specification. So yes, that was all about classification tree editor and later like mutation testing. So I would say thank you very much for your participation. And if we have any question now, we can go through. And later also, if you have any question, you can write us at support@razorcat.com. Okay, so hello, Abdullah. Yes, so we have few questions. Can TESI be used for function and call coverage testing? Yes. Here we did not have the function call, but it will be used for function calls. Like it will check for call coverage, and that you can check here in call trace. For example, you can say in this test item, I did not have any call. So I will say, okay, no calls expected. And if you have any function call, you can select them and put it here and you can test it. And in call trace view here, you can check whether all the call traces were correctly checked or not. Yes, so I guess these questions were already answered in mutation test presentation. Yes, so another question we got is it possible to view the generated source code of test cases that in TESI is generating, so that we can see like how it has been generated? You can go to this location. You can say Alt and double click, and this one. So here you will see how it has been, the generated test or generated code from the TESI for particular test object or particular test cases. So yes, this one we had already seen. Okay, so another. So what languages are supported by Test C? So for this, maybe I can answer you later, and you can write us at support@razorcat.com. And to answer this correctly, maybe I will ask to the team and I can write you back later. Again, so is it possible to write our own test case and run via Tessie? So yes, like you can at least have a template, or there is something called script editor here. And once you go and in script editor, so this is like XML format, and one template is ready. So you can save it and you can edit this independently, and later you can import that script here, and the test data will be taken. So this is one way. Another way is, as I said, the CTE, and the third way, you can export into Excel sheet. The template will be ready, and you can add as many test cases as you want, and later you can import the test. So again, one more question I have got is, instead of bubbling in CTE, can I generate test case automatically using CTE? So we already saw in here, we did not, here you can see we generated all pairs. So we did not have to bubble that time. It takes care, like, all possible combinations it is picking up and it is bubbling. So yes, you can do, if you take this one, generate test cases all pair, or yes. Next. Okay, so I don't see any other question. Okay, so if we have few more questions, so that maybe the Menlo Park team can write us, and I will write you back, and they will forward your answer later. So thank you very much and have a nice day. Bye.
We thank Mrs. Shashinag for providing us the training. We request all the delegates to drop their questions in the chat box. Mrs. Shashi will answer your queries now. Also, to get to know more information on the tool, please write to us at support@menloparktech.com or marketing@menloparktech.com. Thank you.